Okay, here is a video on the 5-step process for predicting redox reactions in solutions. Okay, so we'll do a couple of examples and go over it and go from there. Okay, so these are out of your notes. This is page 17 in your notes. Okay, so step 1, list all the entities present. Okay, so example, suppose a solution of potassium permanganate is slowly poured into acidified iron 2 sulfate solution. Okay, label all the possible oxidizing agents and reducing agents. Okay. Here are 6 hints kind of when you're listening to entities. So like if it says aqueous solution, so right here we have, well, solution, okay, means we're going to have water molecules present. So we know that we're going to have water molecules. And then we kind of, if it says acidified, we know we have H plus molecules. Okay. If it said basic, we'd have OH. It doesn't say that. Some of the oxidizing and reducing agents are combined. So like in this case, so we have permanganate, okay, which is MnO4. Okay. And if it says if we have MnO4 and H plus there, they kind of go together. So we'll write that next, MnO4 minus. These are all aqueous. Well, water is a liquid. Okay, what else do we have? We have potassium, and this is K plus, so we have potassium ions. And then acidified iron 2, so iron 2, Fe2 plus, and sulfate SO4 2 minus. Okay, so that's the first step, writing down everything that's there. Okay, so these are all the entities that are present. Okay, and now we want to label them as oxidizing or reducing agents. So water, okay, and that's where we kind of look over here, find water. Okay, and so water is right here, so it can be a reducing agent. And water is also down here, so it can also be an oxidizing agent. So you have to kind of look for them on both sides of your reduction half reaction table. Okay, H plus and MnO4 are an oxidizing agent. That's up here. MnO4 and H plus. Potassium is way down here. It's an oxidizing agent, but it's a really weak one. Fe2 plus. So Fe2 plus is another one. It can be a reducing agent. It's on this side, or an oxidizing agent. Okay, and then SO4 2 minus. If we look through here, okay, it's up here, but we don't have any of this lead 2 oxide, so that doesn't count for it. Okay, but right here we have SO4 and H plus, so H plus and our SO4 produce an oxidizing agent. Okay, and then we can see it. Sometimes it's in more than one place. Like here, it's with water, SO4 and H2O, so that would also be an oxidizing agent. Okay, so now we've labeled as our oxidizing agents and reducing agents. And now what we need to do, we have to choose our strongest oxidizing agent as indicated in our redox table and write the equation for its reduction. So our strongest oxidizing agent, we want the one the closest to the top. So our MnO4 and H plus, okay, that's like 3 down. It's a really strong one. So we write down its reduction equation just like we see in the book. All right, so that's written down just like we see here, exactly the same. Okay, then we choose our strongest reducing agent as indicated, okay, and write its equation for oxidation. So our strongest reducing agent, okay, if we look, we only have 2 reducing agents. Our strongest one is going to be our iron 2. Okay, we write down its oxidation, so we're going to flip this one. So we got Fe2 plus, and if you see here, they all have the double arrows, and it produces 1 electron plus Fe3 plus. So it's really important that like we're taking the one where Fe2 plus is a reducing agent, not where it's an oxidizing agent. Again, I'm writing down its equation for oxidation. Okay, now we want to balance the numbers. So really now we have our 2 half reactions. Now we can just put them together and balance our overall reaction. So I'm going to go ahead and do that, and then I'll show you what I did. All right, so again, with our two half reactions, we have to balance out the electrons. So I'm taking this, times it by 5. So I times everything in this equation by 5. And then we write down what we're left with. Again, the electrons are the same on both sides, so they cancel out. So this is our overall equation. Now what we do, using the spontaneity rule, so that's if our oxidizing agent is above our reducing agent, okay, it's spontaneous. Okay, and so we just look on here. So we have, this is our oxidizing agent. This is our reducing agent. Since our oxidizing agent's above our reducing agent on this list, it is spontaneous. And we just show that by writing spontaneous above the arrow right here.